Today we from HydroCAD, I will start a design from a diagram on paper. It's now displayed in my screen. And normally when we have a diagram made on a DWG, PDF, or whatever, we look at it and we study it. So let's look at this diagram, and we can see standard patterns. So this is the first NG6 section, and then we have other 4 almost identical, except for 2 relief valves that will put a port to a different tank line. So in this case, I envision a subplate style manifold with pass-through P and pressure and tank line, some NG6 valve, and ports on the front or on the back. So normally when I start designing a block, I always try to figure out where I should put the components to optimize my design. In this case, it's very easy, and this is normally my recommendation. Look at the diagram and try to figure out where to position components to have a better layout. So let's switch to Inventor, and let's start designing. It's not a complicated diagram, so I will not need to get back to the diagram frequently. I will just start my new part, and in a new part, I will now load my MDTools 780 module for Inventor. Everything you see here is also available in MDTools for SolidWorks. So I'm going to do some settings first. I will decide to have not expander plugs for my design. So I will select BSP plugs, but I could select short port or whatever it is. Of course, I'm checking my library, my precision, and I have some standard cavity color that will help me with my design. But let's start placing some items in the block to better understand how MDTools works. So we always start with a rough design. So let's say that this block will be 300 millimeter long, 160 millimeter wide, and 90 millimeter tall. If you remember, we had the 2 flanges. One was 3x4 chord 62, and the other was 3x4 chord 61 for the pressure and tank. So we go in the library and search for a 3x4. So when we place components from the library, we can search just by typing the cavity name, and we search for the component. We type the component ID, let's say that's pressure. If we want, we can define a net, and you can select from the standard net names. Let's say I want the PNet, or you can type in whatever you want. So I could even write my name as a net. That's not important. When you type a net name in your in a cavity, then the drill where you assign this net will take a color and will take a corresponding net. So now this net called Carlo is not defined in my standard color palette, so it will take a random color. I'm just placing my components at let's say 55 by 45 millimeter, and press OK. So this is my first cavity. Then I take my tank port. The port is T, and the net, in this case, let's use a common T. I can rotate, and I can position with a reference to another cavity. So in this case, I will say 60 millimeter 0, so they are aligned. And later we'll see how if the position is good or not. Anytime you place a cavity, you are not constraining to anything. The cavity will be free to be changed face or moved according to what you need during the design process. Now my block had some NG6 valves on top, so I will search for my D03 cavity, and let's just take the P and T, and let me specify A1 and B1 as a net name. And that's my first position, NG6_1, and I position it here. I can rotate, I can place with some precision. Let's say 70, 65, and that's my. Of course, same color means the same net. So we are going to design, and now I did a mistake. So in my cavity, I decided that this drill is belonging to a pinnet, while the other cavity that I have placed in my block is belonging to a net called Carlo. You can change the net information. In this case, I use the easiest way. So instead of Carlo, I will select my net P and press OK. So as you can see now, MDTools has changed the color for the pressure. Now I want to connect the same color. So to make a connection, you use the construction port, insert construction port. We touch the first cavity and then the second cavity. And I think I didn't save my settings, so let me get back. I don't want expander. I didn't apply my settings. I apologize. Let me do again. BSP plugs, all, add, close, apply. So when you apply, you are saving the new construction drills for this current design. Now construction plug from this drill to the other drill. And we can select the size. Let's say that I need a G1/8 BSP plug. Continue, and I want the plug to be on the front face. So any place you position the cavity, then MDTools will make cross intersection center to center, and you can click OK, and this will make the connection. At the same time, we do a construction plug for the tank line, a G1/8, and we place on the back face. Now we want to position A and B. A and B were SA ports, -8. Let's say this is A1. We can skip defining the net information here because we can just click insert, touch the face, and connect to the destination cavity. So when we connect a cavity that has no net definition to a cavity that has net definition in the block, then this new cavity will take the same net information of the cavity in the block. We can control the size. So 17 millimeter is too large for the size of this drill. So we can say, let's make it 8 millimeter and click OK. At the same time, we take the port B1, we insert down here, we connect to the yellow, always with a 8 millimeter diameter. And we can use a reference from the other cavity, and we can say 50 millimeters. So we keep a 50 millimeter distance between those two cavities. Now that we have placed the first section, let's check if we can optimize a bit. So in order to verify the connection, it is very easy now. We have no mistakes at present, but with connection check, we can verify if all the connections in our block are made properly. And actually, in this case, we don't have any mistake because we clearly see with our eyes that all the net are well connected. Of course, things would be different if, for instance, this drill was longer. Now we can see that the blue line is touching the red line. So when we run the connection check on all the block, now this will end up with a wrong connection. And when you click on an item, it will highlight the cavities that are interested by this issue. So this was not correct. Let's do the connection again. And let me save my block. Let's call it subplate. Another important item is optimize the volume. And in order to optimize the volume of the block, of course, we need to pay attention to distance between cavities. So we now want to measure the distance between this drill and this one. So 11.5, that's a lot. And then from this to this, that's also 11.5. So let's say that we can remove 4 millimeters. Let's do something like this. We move multiple, 1, 2, 3, and 4. We move everything up by 1, 2, 3, and 4. This is one way. Instead of removing material, now we are just moving items up by 4 millimeters. Another technique would be click the create command. That is the first command that you run to start the block. But when the block is already there, this command will open a different dialog that allows you to place a plane wherever you want. And now I want to place a plane here, and I want to remove 8 millimeters. So if now I do my distance between these two cavities, I will see that it is 7.5. It is okay. And if I want to verify the wall thickness in my entire block, I can click wall thickness command and specify the 5 millimeters. In this case, it's my default values. I can click start. And as you can see, I have a potential problem here of 3.15 millimeters between the tank plug and the yellow connection line. So in this case, although it's a tank line, the drill are small, this could be enough. We don't want to keep only 3 millimeters. So we move this drill slightly to the right. So 1, 2 steps, it means 2 millimeters backwards. Now that we have made our first section, well, we can see that we can remove some material on this face. Let's make it 140. Should be enough. And also here we can remove some material, 120. Not enough, 125. That's okay. Also, let's look at the size, 82. Let's try to make 80 millimeter. Now we need to copy and have 5 different, 5 identical sections. So we use the copy multiple command for 1, 2, 3, and 4. Done. Distance is 50 millimeters. And sorry, I forgot to select the footprint. Copy multiple 1, 2, 3, 4, and 5. Done. The distance is 50 millimeters, and I need 4 items. Remember, well, you see a preview, so it is always 4 plus the one that you are copying. So this is the number of new stations. Now MDTools is just copying. And now we want just to stretch this drill up to 155. And same here, this one we want to make 155. And we need the other tank lines on the other side. So we can use always the copy command, take the tank line, call it T1. I place it here. I can rotate. And for different face to have a perfect alignment enter to center, you always use the reference, select the cavity and type 0, 0. We do the same for the other pressure line. That's P1. We position here. We can rotate and always a reference to the other cavity at 0, 0. Now we can recolor our block. And we can put some mounting holes. Let's say M8 pass through. We want 4 on this face. Okay. I don't have enough material here, so let me just add a bit of material on the width. 5 millimeters. and the same there. Create on width on the other side. In this case, let's add more, let's say 15 millimeters. If you remember, there were two valves, two relief valves, which we need to place. So our block is almost okay, except for the other valves. But of course, sometimes customers are asking changes. So let's say that now my customer is saying, hey, sorry, I made a mistake. This center position is not anymore an NG6, it's an NG10. So we can always, all these copied items are not identical to the origin. They are identical only because I made them as a copy of the source cavity, but they are fully independent. So we can always use the replace command, select the cavity, and take maybe an NG. Let me go and find my direct control D05. When you replace a cavity, pay attention to following options. Retain drill diameter and drill depth. Sometimes it is very important to retain because I'll show you later for the ports. In this case, retaining the drill diameter and depth does not make much sense because I am replacing an NG6 with an NG10. So I don't need the 6 millimeter diameter. I will need the diameter from the new cavity. So I will uncheck the drill diameter. I can retain the drill depth. So I can click OK, and now MDTools will replace the footprint with the NG10, which is of course larger, so I will need some more material. And in this case also, please notice the tank line, this port is TB and TA. The source footprint had a cavity called T. So by default, if the cavity name is not matching, if the port naming is not matching, MDTools will leave this net as not defined. So what we do is we select the net that is the tank line and the tank. And yes, that's okay. And we do the same here, add it as a tank line. Okay, now of course I needed to extend a bit of my block, so let me add some material on the length and slightly here, and let me add 20 millimeters. Let's see if that's enough. That's good. Let me add 5 millimeters on the right. Five millimeters. Of course, now we need to align a bit our cavities, so we can do a new, we can say, align with this cavity. As well for this, align with the yellow connection. Align this cavity with this one. Now we can make this plug may not be needed anymore. We can stretch this connection and going down. And of course, we want to connect both tank lines. So let me create a construction plug here, a G1/4 on this position. Let me move it slightly there and click OK. So now we did our replacement, the connections are made. We can see some problems here. So let's verify. Well, this issue, yellow with the tank, is now visible. So let's fix it immediately. Let's move this footprint on the Y direction so that we don't have that issue anymore. We need to stretch this drill a bit. And now, in order to optimize the intersections, so as you can see here, this tree is too long, also the other is too long, we have one command that will automatically run for check for all the intersections and optimize the drill depth. This command is called bend, and it is up here. When we run the check bend, we are asked to start verification on all the block. And we have a table of the current depth and recommended depth for all the cavities. Normally I trust all and update. And now MDTools is verifying and fixing all the drill depth for all the cavities in the block. And now if we zoom in here, we can see that the drill depth has been optimized. When it is done, we can just click close and save our block. Let me clean. So now if we run the connection check on this diagram, we will see a lot of issues here. Although the block is well made, but we can see that we have several broken nets. So as you can see, A1 is the same net assigned for all A ports, and B1 as well. So although we know that the block is correct, I don't like to have bad information in the MDTools design. So there is one command in MDTools. It's a bit hidden, so let me highlight a bit. It is called assign net. So this command, when you run it, it will warn you that it is removing all the net information previously defined for the block. So if you design from HydroCAD, I strongly recommend that you never run assign net command. But if you if you design a block from a diagram not made with HydroCAD, then this makes sense. In this case, if you click yes, MDTools will destroy all the net information in the block and will rebuild net information according to how the cavities are connecting each other in the block. So in this case, we will see at the end of this design that all the colors have changed and we have a full control on colors. So we go later and change the color for the pressure and tank line. But as you can see here now, all my different ports have different colors. So if I run a connection check of my block, all those broken net warnings are not there anymore. There is only one issue that was also there initially, and it is not good quality connection here. As you can see, these trees are not touching very well, and we may then later do an inclined drills to do a better connection. Let's leave for the moment. Because now we need to put the relief valves, which looking at the manifold I will put on the back face. The relief valves are where the C10-8 Parker. And port 1 we leave as is. We'll later find which is the port. We wanted to define a net called T1, and that's our relief valve 1, which we can position maybe here. Let's place it somewhere here. And I remember that it was connected to the A port of the second and fourth place. If we go back to the diagram, second and fourth, we have the relief valve 3.1 and 3.2. So let's make an inclined drill, green to this gray connection. So to make an inclined drill, in this case, I will make an offset hole for this cavity. And it's, let's say, 10 millimeters. Non-constrained because later I may need to move it, and I leave at -2 millimeters from that cavity. Now with the stretch drill, I can select this drill and incline up to this cavity to port 1. We can change the inclination. Let's make it 19 degrees. This is fine. We can make it 18. We can extend it, make it 80 millimeters, and we can click OK. This is making an inclined connection. We can later move this drill slightly to the right. And we can match properties this drill with this one to apply the same net from port 1 to port 1 so that they become green as well. So we can stretch this drill and we can stretch a bit more this one. Let's make it 85 millimeters. We can copy the same cavity, so we can use again the copy multiple 1 and 2. Done. And we want to replicate this on the second position. So let's say that we need a minus 150. That's too much, minus 120. Let's measure the distance. So we can use inventor measure command to measure distance. So the path is 125. So let's do the copy multiple 1 and 2 and minus 125 and click OK. Now, of course, the net is different color. We need to match properties from this to these two. And I want to copy the net information between the port 1 and port 1. Now we need to connect the tank lines. We realize that this mounting hole is not in a good position. So we move it to the center. And we want to make a construction plug on port 2 and place it on this face. Let's move it up tangent. That's a bit risky. Let's leave it here for the moment, and then we move the flange down. So we can use the move multiple command to take the flange and all the construction plugs linked to the flange down by, let's say, 5 millimeters should be enough. We can see this plug is really in a bad position. So let's change face and place it here. And let's make a connection inclined up to the orange connection. And now we also want to incline this drill, allow change by 9 degrees. All the tank lines of the two relief valves. So we have A2 going into the relief valves, and this one is another tank line. Let's say it's a G1 by 2 BSP port, T1. We put it maybe here. When we make a construction plug, 1 by 4 is enough on the bottom face. Let's move this drill up. Let's reduce the drill. Let's recolor. Let us move a bit this drill to the left. And I want also to reduce a bit the inclination. Let's now verify the connections in the block. So there are some, well, there is a dead area, working area intersection here, highlighted here, which is basically this drill is touching this area here. So we are going to fix, and there are some poor connection list here. And let me show you an example of those poor connections. Basically, when we move down all the tank lines, this drill is there. So we will use again the bend command to optimize and get a good connection across all the block. So first, let us move this cavity slightly to the left, and we fix one issue, and we run the bend command on all the block. As you see, all those are short drill. 43 should be 48. All update. Now, if we run again the connection check in our design, we should not see any issue. Maybe here there could be possibly a bad connection, but that is okay. No, still it's good enough. So in terms of connection, we did a good job. Now we want to verify if the wall thickness of this block is okay. So we do the wall thickness check. Let's say 4 millimeters on all the block. There may be some issues here. And really what we need to do is then to do the modification required. Let's look at this one. This one is critical. And this one we cannot leave as is, because in this case it says 0.7 millimeters. So this drill is too close to the bolt hole. So the same problem will be on the other drill as well. So let us move this drill down, let's say 2 millimeters. And since it is a relief valve, we can also reduce the drill. Let's make it 8 millimeters. It's on a 6 millimeter, so that will be enough. So we can align this cavity with this one, so they get the same Y position. And we can use the match properties to copy the same geometry between two different drills. We do again our wall thickness check for mm, and now that issue should not be there anymore. There could be other, but I'm not going now to spend too much time on looking at all the issues. This one also is a small issue, but it is between bolt holes, so we can really skip it. And again, we can click and view all the other issues. Let's say that the block is okay for us, and we wanted to insert some engraving. So with manage command, we can attach an engraving to a cavity. We touch the cavity and touch the face, and click engrave. Attach, touch the cavity, touch the face, and click engrave. When there is a standard pattern, we can use the copy command to copy engravings. Let's use the pattern 50, and the count is 4. The pattern is not exactly 50, so later we will need to move some engravings. And we can easily move engravings just by using the arrow. And we can align engravings. So in this case, we can move them and align engravings. The pattern is no more 50 because we really added a NG10 valve in the middle. And same, we could add other engravings to other ports. I want to show you just a small item again in the part, and then we switch to assembly and machining drawing. If there are no questions on the 3D modeling part. Basically, I don't like the colors here. So if you want to change colors, you just go to the net, find out the net that you want to change, let's say net 6. Right click, change color, and you select a different color. This will change the color for that net. Also the big orange net, not this one, it's this one. Change color, and if you want, you can also change name. So double click and you can say that's my P2, enter. And so you can really, on a design block, when you run the assign net command, automatically you get a new net for the block, and then you can rename to have a better understanding of how the block has been designed. Let's save and let's go to the assembly drawing. So I make a new assembly, and I will just automatically plug my block. That's my subplate. All my plugs are defined in the MDTools library, so no time is wasted for the plug assembly. And for the valves, as I have not started from HydroCAD, I don't have data information for the 3D model, so I will just manually load components, sort by cavity. So the RV1 are Parker A04B. The NG6 are Parker D1VW. We can see a preview, and that is okay. And the D05 also as well. We can take the D3W, and we can view a preview of the block. Update all, and the assembly is ready. Of course, we could use the same command to assemble flanges and fittings, as I have shown in other webinars. Let me save my assembly. And if there are questions, feel free to fill in the chat. I will be able to answer. So I go back to the block because I want to give an additional information. So this is a very standardized block with a lot of identical features in the same face. So using the machining ID is a good technique because the machining ID can give identical IDs to identical operations in the block. So in this case, for example, there are a lot of bolt holes identical, so they will be grouped in the drill list. And at the end, it will be a very compact drill list. So by generating the machining ID, we just click OK, and MDTools will give to each cavity in the block a unique ID, 202A, because there are other identical cavities in the block. Now we go to the machining drawing. And in the MDTools 780, we can create views, and we select our block, which is the subplate. We can define how it must be projected. So in this case, it's a long block, so I like to have the 6th view down. Otherwise, you have these two options, the 6th view on the right or down. And everything default, we can position the block. It's a bit stretchy in an A1 page, so let me just change to an A0, although it could fit. When you change paper size, you could either move again, or to me it's much easier, since the creation of the views is very fast. When you recreate them, it will be automatically in the center of the page. So sorry, I took the wrong model. I was saying it is faster, but in this case it ended up not being fast. Please remember to select the correct 3D model here. Yes. So now we want to describe our block with some more cosmetics. So we want to show the footprint outlines. This will put the outline of the flanges and of the NG6s and NG10 valves, and also with the port names. We wanted to highlight the construction plugs. So we want to put a cross on all the cavities that must be plugged. We want to show the machining IDs. all the machine IDs will be positioned automatically in the block. If you don't like the position, double click and change the position and close the sketch. So all the machine IDs in one phase are in one sketch. So if you need to modify, you double click, you move some text, and then conclude. This is the only cosmetic work that you must do in your machining drawing. Of course, we need the dimensions, so auto dimension, and we start placing all the dimensions in all the block. In the dialog, you can define if you want to put the dimensions on all the cavities in a footprint or only in the origin of the footprint, and where you want to position the dimensions. So for instance, as you can see here, on the bottom face, I have only dimensions on the bottom and right. And this is controlled by this option here. So here you can define if the dimensions are distributed across the view or only on particular side of the views. The drawing is almost complete. We can put a machining chart. So now it's loading the cavity list, and you can create custom machining chart formats. I have a standard grouping by quantity. So in this case, it will be a very compact drill chart compared to the number of items in this block. We can insert and maybe from here to here. And this is the drill chart controlled by the definition of the cavities in the MDTools Library Manager. As you can see, item 102 and 5 by 10 with a drill of 4.2 by 13, there are 16 identical items in the same phase. And if we go here, we can see that 102A, B, all those the M5, and then we have the M6, 4 items, and so on. We can get a list of cavities available in the block, and you can decide which items you want in a list of cavities. This is an example. If you want to know how many plugs you have in a block, you just create a list of cavities. Of course, you could count how many plugs, how many 3D models you have in the assembly. But if you don't have the assembly, you can just run the cavity list, select only the X drill plug, and click OK, and insert in the drawing. So in this case, we can have a list of all the construction plugs. So we have 9 1x8 and 3 1x4 plugs.